Hello everyone, today we will learn about roots and fractional exponentiation together. Can you think of what we learned in junior high school? The quadratic root, right? Isn't it a bit unfamiliar to non-numeric powers? Next, let's review the relevant knowledge we have learned in the past together. In junior high school, we may not particularly emphasize the concept of integer exponentiation. We often talk about the concept of exponentiation. We have also learned some properties of power operations. In the previous chapter, when we were studying functions, we learned about power functions. Some of the content is just preparing for our class today. Okay, let's learn together now. In junior high school, we said that multiplying NAs can be written as the nth power of a, or pronounced as the nth power of a. This is called the nth power of a in terms of the operation result. Here, a is the base number and n is the exponent. When n represents a number, it obviously refers to a positive integer, so we call it a positive integer exponent power. We also learned about negative positive exponential powers. The negative p power of a, where edge p is a positive integer, therefore negative p is a negative integer. We write it as 1p power of a. So, regarding the power of 0 exponent, I think everyone will be very familiar with it. The power 0 of a is equal to 1. Note that it is a number that is not equal to 0. Let's take a look below and see if these are familiar to you. Same base power multiplication, base invariant exponent plus power multiplication. Multiple invariant refers to the power multiplication of the product. Each factor is multiplied separately, and then the resulting powers are multiplied. When we talked about functions in the last chapter of high school, we learned about power functions. If the area of a square is s, then the side length c of this square can be expressed as the root s. Then the root s can also be expressed as a half power of s. What are the exponents of powers that we need to encounter in junior high school? How is power defined as a new mathematical object? What are its properties? What can it do? What can we study? This reminds us of the operations we have learned. If the square of x is equal to a, then the square root of x and a, and if the cube of x is equal to a, then it is called the cube root of a. The square of plus or minus 2 is equal to 4, the cube of 2 is equal to 8, and the fourth power of plus or minus 2 is equal to 32. The index can take values of 2, 3, 4, and 5. We generalize it. If the nth power of 2 is x, then plus or minus 2 is the square root of 4. We call 2 the cube root of 8, plus or minus 2 the fourth root of 16, and plus or minus 2 the fifth root of 32. What do I call to x at this point? 2 is the nth root of x. If the nth power of a is equal to x, how would you proceed with the description? Okay, let's make this definition below. If the nth power of x is equal to a, then x is called the nth root of a. N is a positive integer greater than 1. We know that the power 5 of 2 equals 32, so what should 2 be? 2 is the fifth root of 32, and the fifth power of negative 2 is negative 32, so negative 2 is the fifth root of negative 32. The third power of the square of a is equal to the sixth power of a, so the square of a is the third root of the sixth power of a. Okay, everyone, check if these indices are odd. When n is odd, the nth root of a positive number is a positive number, while the nth root of a negative number is a negative number. We use this symbol to represent the nth root of a. We will further familiarize ourselves with it by giving some examples. The application can know that the fifth root of 32 is 2, and the fifth root of minus 32 is negative 2. The cube root of a is the square of a. What if n is even? Let's take a look. The fourth power of 2 is 16, the fourth power of negative 2 is 16, and the fourth power of positive and negative 2 is 16. We note that when n is even, the nth root of a positive number consists of two opposite numbers. There is a very important difference between n being even and n being odd. In mathematical terms, let's take a look at the positive nth root and positive nth root of positive number a. The two can be combined and written as positive and negative nth roots a. A must be a positive number. Carefully compare what are the differences between n being even and n being odd. This is beneficial for us to independently handle some problems in our future studies. The positive fourth root of 16 is 2. The negative fourth root of 16 is minus 2. The square root of plus or minus 16 is 2. We just talked about the even root of a positive number. Negative numbers do not have even roots. Any square root of 0 is 0. So far, we have talked about the odd root of a number, the even root of a positive number, and the nth root of 0. We call this equation a root equation. Among them, n is called the root exponent, and a is called the square root. If n needs to be equal to 2, do we call it a quadratic radical? We know the nth radical. What are its properties? According to the definition of an nth root, its nth power product is equal to a. In middle school, we once said that the square of the root a is equal to a, which is a property of a quadratic root. Today we are talking about nth roots. For example, the square of root 5 is 5. The fifth power of negative 3 is negative 3, and the fifth power of the root is negative 3. When we were in junior high school, we once considered what the square of a under the root sign is equal to. Now, is it natural to propose n times? Does the n power of a under the root sign necessarily equal a? In the previous study, we mentioned a problem. When n has odd numbers, there are also even numbers. Let's take a look at some specific questions. The square of 2 under the root sign is equal to the square of 4 under the root sign, which is equal to 2. The square of negative 2 under the root sign is equal to the square of 4 under the root sign, which is equal to 2. The cube of 2 under the third root is equal to 2 under the third root, and the cube of negative 2 under the third root is equal to negative 2 under the third root. The fourth power of 2 under the fourth root is 16 equal to 2 under the fourth root, and the fourth power of negative 2 under the fourth root is 16 equal to 2 under the fourth root. What did you observe? Root index. Is it odd or even? Let's summarize the properties of the n radical. When n is odd, the nth power of a at the nth root is equal to a. When n is even, the nth power of a at the nth root is equal to the absolute value of a. So when a, it is a, and when a is less than 0, it is negative a. Let's take a look at this set of exercises. Please first look at the root exponent, whether it is odd or even, and then choose our calculation method. The root exponent is 3, which is an odd number, so it is equal to -8. Looking at the second question, the square of -10 under the root sign should be the absolute value of -10 equal to 10. Let's take another look at the fourth power of the 3 minus fraction under the root sign. The root index is 4, which is an even number. What do we need to judge? Judging the positive or negative of the 3 reductions will help us resolve the absolute value. Let's take another look at this question. When it is equal to the absolute value of a b, do we have any information to determine that a and b are closely related? No, so we need to write down all possible outcomes. Please pay attention to this matter below. 5 times the root of a to the power of 10. The 10th power of a is equal to the 5th power of a's second power. So if we consider the square of a as a whole, then according to the properties of the nth radical, it can be written as the square of a. The exponent 2 of the square of a is now compared to the root exponent 5 and the exponent 10 in the open mode. These 3 numbers can be written in the form of 5/10 if they satisfy the condition of 2. A radical form is written in a power form, and the exponent of this power is in fractional form. Let's take another example, the 12th power of a under the third root. Similarly, we consider it as the third power of a's fourth power. So, it can be written as a to the power of 2/3. You can also give some examples like this. When the square root is written as a power, if its exponent can be divided by the root exponent, so the root equation can be expressed in the form of a fractional exponential power. You will definitely raise it if it cannot be divided. Can roots still be expressed in the form of fractional exponential powers? When we introduce a concept or rule in mathematics, we always hope that it will blend with the existing concept and rule. Have you ever had such a learning experience? Can you give some examples like this? We write the square of a under the third root as the power of 2/3 of a. When the root b is written as half the power of b, and the third power of c under the fourth root is written as 3/4 the power of c. Can we continue to satisfy this property? Through calculation, we found that writing roots as powers still satisfies their original properties. Just now we said it could be divided, now we say it cannot be divided. So this unification provides rationality for this regulation. The positive fractional exponent of a positive number. We say that the power of a to the nth root is m, and we write it as the power of a to the nth power, in the form of a fractional exponent. Here, a is a positive number, m and n are positive integers, where n still needs to be greater than 1. Now we are talking about the positive fractional exponent of positive numbers. What about the negative exponent of positive numbers? We still use this form, the negative nth power of a. The form of a is 1n to the power of m, and then written in root form. Please note the conversion between our different algebraic forms here, and also remind everyone to pay attention to the range of letter values. What questions do you think should be raised below after discussing the positive fractional exponentiation of positive numbers and the negative fractional exponentiation of positive? We stipulate that the power of the positive fractional exponent of 0 is equal to 0. The negative exponent of 0 is meaningless. So at this point, we have obtained such a property. Please pay attention to an important topic we have learned today. We have changed the form of exponentiation from integer exponentiation, which we are familiar with before, to fractional exponentiation, which we are now familiar with. The operation rule of integer exponentiation still applies to fractional exponentiation. Please pay attention to the range of values for r and s. Below, we will familiarize ourselves with the algorithm for exponentiation of fractions that we have just learned through some questions, the second third power of the first 8. Question 2, 16/81 to the power of negative 3/4. Let's see, 2/3 of the power of 8. 8 can be written as the cube of 2. We still use that the nth power of a's mth power is equal to a's m multiplied by the nth power, but now m and n can be rational numbers. The square equal to 2 is equal to 4. How should we deal with the negative 3/4 of 16/81 first? Let's first solve the negative sign problem in the negative score index. We write the negative sign in the index as the power of 3/4 of 16/81, and 81 out of 16 is written to the fourth power of 2/3, which ultimately equals 27 out of 8. Let's summarize today's lesson together. I believe that fractional exponentiation must have left a deep impression on you, and during the process from integer exponentiation to fractional exponentiation, have you experienced your progress and the development of mathematics? That's all for today's learning. Goodbye.